All right, now the last thing I'm going to, well, I lied. The last two things I'm going to tell you, I have to look at your paper. You are now going to complete the two next pages in your packet. So, and it breaks it up for you, so it shouldn't be, there shouldn't be a whole lot of confusion on what to do here. So there's some practice problems, and then it talks about we have some perfect square trinomials and a difference of squares for you to work out. If you have any questions while you're working through this, you know the many ways that you can be in touch with me, and I most certainly will get back to you just as soon as I can to make sure that you're good to go. And I think that's it. Just so you know, that little picture that you see, that's my cat. She was helping me lesson plan last night. Her name is Remy, so it's a lot of effort that went through with this plan. All right, so I hope you all are well. I miss seeing you, and I hope to see you soon. Bye. In your notes, you'll see where I've referenced two different sections. One, talking about how these special products are made, and then the second is the actual factoring of the product, which is the polynomial that we're looking at. So I've printed out your notes. I know it's a little lengthy today, but it's because these charts will be very beneficial. We're going to be talking about perfect squares and difference of squares. So in your chart, you'll see where I've broken that up. We have two types of perfect squares. One that's a sum of a perfect square, and the second is a difference with a perfect square. So let me remind you that a perfect square is a number that you can take the square root of and get a whole number. So such as if I gave you the number 16, we know that the square root of 16 is 4. If I gave you 81, that's a perfect square. But if I gave you, let's say, 92, not perfect. So if it's a perfect square of a binomial, those pieces of information come into play again. So let's take a look at it. I'm not going to write everything from your notes because there's so much of it. I'm just going to pick up pieces, make sure I explain it. So in your notes, I gave you this in your first chart. This is the sum of a perfect square, or the perfect squared sum, because I have an addition sign meaning sum, and it's a perfect square because let's say if I just had 5 squared here, that would produce 25, and we know that 25 is perfect square. So if I square this binomial, it's going to create a perfect square of a binomial, thus the name. All right, so the next part of your notes show where if I were to actually multiply out this perfect square binomial, this is what my answer would look like, where A is standing for a value, B is in place of a separate value. All right, this is the form that we're going to work with. So if I give you any type of polynomial, you'll be able to identify that the patterns fit this perfect square with a sum. All right, so far so good. So I really want you to notice a couple things here. A squared would produce a perfect square. All right, so this A squared would be a perfect square. B squared would also produce a perfect square if we knew what either one of these values are. And then in your notes, the other part of information that you should notice from this form, I have whatever A is, not A squared, whatever A is, and then what B is, not B squared, just B. If I took those two values, multiplied them together, and then multiplied it by 2, it would create whatever my middle term is. All right, so that's a product of the second term from the original binomial multiplied by 2. Right, so what I can conclude from that information is if I have a polynomial that fits this form, which we'll explain how it fits that form in just a second, I can refer back to certain pieces of that polynomial to jump into this setup of the perfect square factoring. All right, so how would I determine if a polynomial fits the form of a sum of a perfect square? Would be whichever number and variable are my first term. If I could take the square root of that information and it's perfect, that's the first step in the right direction, saying that I could potentially lead to this form. The second would be, can I take the square root of my last term as well? If so, I'm still going in the right direction. And then finally, if I can take the answers to those two square roots and then multiply those two pieces together and by 2, it would create my middle term, then I have a perfect square that would factor into this form. All right, so I know so far it's still probably a lot of gibberish because I haven't actually given you an example. So I'm going to give you a different example from your notes to see if we can actually make this work. All right, so I'm giving you the example 25x squared plus 110x plus 121. And we are going to factor this polynomial, but we'll first see, is it a perfect squared polynomial? Excuse me. So my steps would include checking to see if the numbers that I have here, as well as the variable of the first term, if I have perfect squares. So that just means I'm going to take the square root of both of these, and if I get a perfect square, if I get a whole number answer, then I'm in the right direction, or heading in the right direction, if I could speak a little bit better today. All right, so can I take the square root of 25 and get a whole number? I can, it's 5. And then, can I take the square root of x squared? I can, and that's x. So far so good, I have a perfect square. Now I'm going to take the square root of 121. And we know that that's 11. So I have a perfect square for my term of A and B. Now what I want us to do is we are going to see if I can create 110 by multiplying A, because this is A and this is B. If I can multiply 5, 11, and 2, because 2AB, and get 110. So we know that 5 times 11 is 55, times 2 is 110. So yes, I did get my two perfect squares, and I created my middle term. Sorry, that's my cat that you hear. And I created my middle term by multiplying 2 by the A and B from right here. All right, so now that I've done this, I have all of the pieces that I need to factor into my original binomial that I intended to do with this problem. So we know that we have A is 5x, we have B is 11. This is not important whenever I factor, because this polynomial fit this form. Now I'm going to factor into this form, meaning I just need my A and my B. All right, so let's give that a try. I have to have A, which is 5x, and B, which is 11. And we know that this is a sum because this has an addition sign. It's a positive, therefore this would be plus. And then finally, I have an exponent of 2 because I have a perfect squared binomial creating this polynomial. So my answer is 5x plus 11 squared. I hope that made a little bit better sense to you compared to just reading your notes by yourself. All right, so now let's work our way into not just a perfect square that has a sum, but now a perfect square that has a difference. And it's so similar with just one slight change. All right, so at this point, I have a perfect square that has a difference, meaning I have subtraction in the perfect square. Now notice how when this addition changed to subtraction, my middle term also changed to a negative, because if let me get a hold of all my markers. If I were to take this binomial and square it, I would have a minus b times a minus b, which we know would still create a positive, b squared, but a negative plus a negative continues to give you another negative. All right, so what we're checking for with this type of polynomial, so let's say that you were given a polynomial where you had a squared minus 2ab plus b squared, something in that form that is, we're checking to see, yet again, whichever number is in place of a and in place of b, can I take the square root of that number and then the variable in my first term and get a perfect square. All right, and then we're going to check the middle again, meaning once I've taken the square root of whatever's in this location and in this location, those answers, so that a and b multiplied by 2, would I get the middle term that's in the polynomial that was given to me. All right, so let's try that out. Now, at this point, what I want you to remember is you have some red flags that should tell you I have a perfect square polynomial, and it's when you have those perfect squares. All right, so from both the first and the second. All right, so we are going to check the given polynomial to see if it's a perfect squared polynomial. So just as though we did last time, we're going to take the square root of our first term, the square root of our last term, and see if they were perfect squares. So we know the square root of 4 is 2, and the square root of n squared is n. All right, so that one checks out. Then we know that 49, the square root of that 49 produces 7, so we're on the right track so far. It looks like we might have another perfect squared binomial. All right, now what we're going to do is take the answers that are a and b. This is my a and this is my b. We're going to take those two numbers, multiply it by 2, and see if it would produce the middle term that we have. So we know 2 times 7 is 14, times 2 is indeed 28, so that checks out. And then the last thing I want you to notice is, yet again, I have a negative, so a negative term in the middle. Therefore, I have a difference whenever I set up my factorization. All right, so let's give this a shot. When I am factoring out this polynomial, I know a is 2, and more specifically, I have 2n. So my first term is 2n because I have my a. Then I'm going to drop down a subtraction because I have a difference. I have a negative as my middle term. And then my term of b is 7. And then finally, it's a perfect square, so I'm going to make sure I square that binomial. And that's going to run into my equal sign. So your answer is 2n minus 7 squared. All right, hopefully not too bad. All right, let's move on to the last special product that you will see. All right, guys, so our last special product is called a difference of squares. The reason it's called a difference of squares is because when I would multiply this first binomial by the second, creating a product, which obviously is the answer I have here, what would happen is my middle terms would end up canceling out. So let me show you what this looks like. So if I had my first my first a and my first binomial distributed, and I have a squared, and then I would have minus ab. Then I'm going to distribute my b, and I'd get plus ab, and then I would get minus b squared. We can see right here that these two terms would cancel out, producing a squared minus b squared, which is the answer that I have on the right side of the board. So we have a special product because the middle term is canceling out. And we also still have perfect squares. So if you ever see a polynomial where you only have two terms and that middle term's not there, check to see if it's a difference of squares. All right, so let's give this a shot. It probably would help if I explained it first. Hold on, I'm sorry, I'm not quite awake yet. So again, I don't have a middle term. That should be a pretty big red flag. I might have a difference of squares. So the next two things I want to check for would be my first and my last terms. Are they perfect squares? Just like you did in the first two types of problems. So if I took the square root of a squared, I'd have a. If I take the square root of b squared, I'd have b. So let's try this out with an example so it makes a little bit more sense. All right, so the example that we're working with right now, I have 64m squared, and then I have a minus 100n squared, which that's one thing I didn't mention. You should always have, if you're checking for difference of squares, it should always have that subtraction sign. All right, so I don't have a middle term. That's just screaming to me, check to see if you have a difference of squares. So that's what we'll do. We're going to check to see, do I have a perfect square as my first term and as my last term? If I do, then that's going to lead me to a very quick factorization over here. All right, so we should all know that 64 is a perfect square. It's 8. Then m squared, the perfect square of, the square root of m squared is m. And then I have the square root of 100 is 10, and the square root of n squared is n. All right, so I have some perfect squares. All right, that's going to lead me to a pretty quick factoring of this problem here. Now, what the answers are, just like before, this 8m is A, and this term of 10n is B. So let's throw those into this form right here. All right, so I have A first in both of these. A. All right, and then I'm going to take my term of B second. Oh, I did not leave myself a whole lot of room, so let's try that again. That's not going to work. All right, and then the last thing that we have to remember is with the difference of squares, I have a binomial with a sum, and I have a binomial that is a difference. This is your answer. All right, so I've given you 3 examples of what would happen if you had a product from either a perfect square that's a sum, a perfect square that's a difference, and then a difference of squares. And then I led you through your notes to figure out, hey, I see a pattern here, what should I check for? So what I want you to take from this is if I give you a polynomial to factor, and you can see, or it looks as though the very first term and the last term are perfect squares. Go through this process, check to see if they are perfect squares, and then check to see if that middle term is created by multiplying A by B, then by 2, if you have a middle term. That will lead you to a pretty quick way of factoring that problem. So look for those red flags. And then finally in your notes, there are some steps for you to look through. So if this chart or this did not help you all that much, if you're still feeling pretty confused, make sure you look in your notes where I've written out the steps for, hey, these are the things that you need to go through to actually see if I do have the type of problem that would lead to a quick way of factoring. All right, guys, one last bit. If you happen to have any questions, as always, please reach out to me. You have many ways to do so. Since this is the first time for this packet that I have a video, I'm just going to remind you, you can always live grades message me, email me, send me a text on Google Voice, send me a message on Remind, any of those ways. That way I know that you need help. The only one that I don't know immediately that you need help is live grades. Not to discourage you to use that, but I won't know until I log in that you had a message. If you're okay with that, that's great. And then regarding Google Voice, just so you all are aware, if you call that number, it doesn't ring on my phone. The only thing that I'll see is that I had a missed call after the phone is hung up. So please just text message that one. That way I know that you need help and I can message you back or I can give you a call. So besides that, I think you have everything you need for days 18 and 19. Again, I hope you guys are doing well. I miss seeing you. Bye.